Welcome back to Advanced Microcontroller series. In the previous session, we discussed about microcontroller timers. In today's session, let's discuss about the configuration of timer. We'll see how to have a timer counted with respect to built-in timers of PIC microcontroller. Most of the microcontroller having built-in timer and PIC also having built-in timer. Let's open the data sheet PIC16F877A. So here in the table of contents, so here you can see timer. So how many timers you are able to identify here? 3. Timer 0, timer 1 and timer 2. So our PIC microcontroller having 3 built-in timer. Let us start with timer 0 module. And here you can see how much is the how much is the resolution. So it is 8-bit, isn't it? 8-bit timer or counter. 8-bit timer or counter. So resolution is 8-bit. Timer 0 module configured as a counter. That's why it is counter. It is readable and writable. 8-bit software programmable prescaler. So what type of scaling the timer 0 supports? That is prescaling, not support post scaling. And at what point overflow happens? FF200. So FF in decimal is nothing but how much? 255. So whenever there is a overflow happens from 255 to 0, an interrupt happens. And if you configure timer as a counter, the tick happen after an event occur, means upon occurrence of an event the tick will happen. So if the timer is configured as a timer, it is going to make use of internal clock. So if the timer is configured as a counter, it is going to make use of external clock. So edge select for external clock. So if you are going to use external clock, then you need to select this one, edge select. Okay, let's open the code. MPLAB XID. So here close project, file, open project, and here 1 second timer. So here I am going to choose setting the internal clock. So T0CS is equals to 0. So before that, so here I am not going to select the external clock. So edge select is not required in our code. And here LED array is equals to 0. So initially we considered all LED turn off. And here we using single LED that is connected to RD0. That is LED 1. So we are using. And here you can see LED array DDR equals to 0. Why it is 0 means here we clearing the bits. Why? Because LED is a output device. And init timer 0. So this is a function. So it is separate peripheral and its code written in timers.c. So here is the initialization. So whenever you have to configuring a specific peripheral, you will have to look into a register. So what are the registers available? Let's see. Go to the data sheet and scroll down. And here you can see we having 3 registers, TMR0, int con and option reg. So timer 0, here you can, TMR 0, this is the register associated with timer 0. So what is the time is ticking? 0, 1, 2, 3 up to 255 is being stored inside the TMR 0. And next is the int con and option reg. Here you can see it having 8 bits. Both are having 8 bits. See some of the bits in grey background, right? So why it is grey? It indicates those bits does not belongs to the particular module, that is timer 0. They belongs to some other module. So here we having INTE, means what? External interrupt enable bit. And here we also having INTF, means external input flag bit. And here we also having INTEDG. So this also used in external interrupt in order to select whether falling edge or rising edge. This one INTEDG. Let's configure the register. And here we having option reg register. So R or W means what? It stands for readable or writable, read or write. And this one is the default value. And here it having 8 bits, bit 0, bit 1, bit 2 up to bit 7. Total 8 bits it having. And here you can see bit 7 and bit 6 not belongs to this timer 0. It belongs to some other module. And here you can see bit 5, T0CS, timer 0 clock source select bit. So if T0CS equals to 1, then you are going to select external clock. If T0CS equals to 0, then you are going to select internal clock. So here in the code we are going to select internal clock, not external clock. So here we having T0CS equals to 0. And next is the bit 4, T0SE, means timer 0 source edge select bit. If you are going to select external clock, then you need to select this one. Which edge you are going to select, high or low, high to low or low to high. So if you are going to write T0SE equals to 1, then that is falling edge. If T0SE equals to 0, then it is rising edge. So here in the code we are going to use the internal clock, so we are not bothering about this one, T0SE. And bit 3 is the PSA. So if I want to use prescalar, then PSA equals to 0. I need to write in the code. Prescaler is assigned to watchdog timer. So here you can see if PSA equals to 1, so it assigned to watchdog timer, but in our code we already disabled it, so no need to worry about it. So if you are going to write PSA equals to 0, means you are going to use prescalar concept, then here we having 3 bits. So these 3 bits are used to select the range when you are going to select the prescalar. So range means whether it is 1:1:2 or 1:4 or 1:8, like that you are going to select some range. 1:16, we having other also, 1:16, 1:32, 64, then 1:128, and we also having 1:256. So you are going to select some range. But in our code we are not going to use pre-scalar concept. So no need to worry about this. Just I am going to write PSA equals to 1. So here in the code you can see PSA equals to 1. If you are making use of external clock, then it doesn't behave as a timer, it behaves as a counter. TMR0 IE equals to 1. Timer 0 interrupt enable bit. We need to enable this without fail. Then TMR0 IF means what? That is flag bit. And this is about the initialization, and here we having GIE equals to 1, enable all the global interrupts. Then it comes to the main function, and here we having while of 1, and here you can see there is nothing. Timer is turned on and it starts ticking. It's ticking like 6, 7, 8 up to 255 it's ticking. When it reaches to 255, it rollovers to 0. Then it will go to the control will go to the ISR here. So here flag bit is equals to 1. Here you can see timer 0, TMR 0 equals to TMR 0 plus 6 plus 8. This one we already discussed in the previous session. And here you can see count value. If plus plus count equals to 20,000, then count equals to 0, and here toggling happens. This is about the code. Just save the code, build it, then open PICSimLab and load the hexa file. So 1 second timer, distributive default production hexa file. Then here you can see LED is toggling. This is the output. Now LED is toggling for 1 second. Now how to make this LED toggle half second? So how to achieve half second? So here we having formula, right? So here in time you need to write 0.5 instead of 1. Then you will get the count value. So here you will get the value 10,000. Check it using the same formula. Then you will get 10,000. Then click build. After that go to PICSimLab Simulator. Then file, reload last. Same code. So here you can see LED toggling for half second. So this is about the LED toggling. Now let's use the pre-scalar concept. Now go to the code, and here I need to select pre-scalar code. So here we having 1 second timer pre-scalar, right? So go to the code, the same code, and here you can see T0CS. So here also we are going to use the internal clock, and PSA equals to 0. Here we using the pre-scalar concept. That's why PSA equals to 0. When you are going to use pre-scalar, we need to select range of these 3 bits, isn't it? These 3 bit range we need to select. So here for 1:16 bit, what is the value given? So here you can see 0, 1, 1. I am going to select 1:16. Then here we need to use this bit value. So PS2, we having PS2, then we having PS1, then we also having PS0. So we need to use that bit value, right? That is 0, 1, 1. So if I write like this, then it will going to use this one 100, right? So 100 means it's going to use this 1:3 32 scaling. So don't change the order, you need to write as it is 0 1 1, PS0 1, then PS1 1 and PS2 equals to 0. So now we need to find the value of count. So now how to find the value of count? So ticking 256 minus 6 is nothing but 250 and 200 nanosecond. So nano means 10 to the power minus 9. And here we using the scaling 1:16. You will get some value and 1 divided by that particular value is equals to 1250. So here where we need to write this value in the ISR, you need to write 1250 value. So let's see the output now. Click build. Now go to the PICSimLab Simulator and here you need to choose load hexa file. So here 1 second timer prescaler, distributive, default, production and hexa file, and here you can see the output LED is toggling. So now let's discuss about the timer 1 module. So in timer 1 module is a 16-bit timer. So timer 0 is 8-bit timer, isn't it? This is 16-bit timer which consisting of two 8-bit registers which are readable and writable. The timer 1 register pair with TMR1H is to TMR1L increments from 0000 to FFFF and rollovers to 0000. In the 8-bit it store value from 0 to 255, but here it store value from 0 to 65535. So here we need two 8-bit registers, isn't it? So I am not going to configure this timer, it takes huge time. So let's discuss about timer 2 module. So timer 2 module, so this is a 8-bit timer, so means resolution is 8-bit resolution with a prescaler and a post scaler. What type of scaler it is? Both. It supports, it allows both. It can be used in PW time base for the PWM mode of the CCP modules, and TMR2 register is readable and writable and is cleared on any device reset. So here we having option for prescale 1:1, 1:4 and 1:16. That is selected by control bits T2CK PS1 is to T2CK PS0, T2 con from bit number 1 to bit number 0. So timer 0 cannot be configured as a counter, isn't it? Here they didn't mention about counter. And here the timer 0 module has 8-bit period register which stands for PR2. So timer is ticking for 0, 1, 2 up to where? Up to the value of PR2. If PR2 value is 200, then what will happen? Timer starts ticking from 0, 1, 2 up to 200. When it reaches this value, it rollovers to 0. And interrupt is generated. So here you can see the block diagram. So timer 0 register, and here we having PR2 register, and here we having comparator. So let's configure 8-bit register. Very first, here you can see this is 8-bit. Let's configure. So here you can see we having 8-bit. So timer 2 is 8-bit register. So the very first bit is unimplemented, isn't it? And here you can see timer 2 output post scale select bits. So these three are post scale select bits. But okay, I'll open the code. So in the next project I'm not going to select the post scaling. I am use the pre-scaling like previous one, like the previous code. I am going to use the pre-scaling concept. And here also I am going to use 1:16. Here you can see PSA equals to 1. Yeah, and for pre-scale, so this is about the post scale select bit, and here we having pre-scale select bit. So here we having options, right? Pre-scaler is 1. So if it is 4, then if it is 16, we having bit values are there. So here we are going to select 1:16. 1x. X means what? Bit is unknown. Either you need to write 0 or you need to write 1. Anything you can write. So here PSA equals to 1. And here you can see T2 CK PS0 and T2 CK PS1 both are equals to 1. Here we are going to use 1:16, and this one T2 CK PS1 and T2 CK PS0 both are considered as 1. And here we also having timer 2 on bit. If it is 1, then timer 2 is on. If it is 0, then timer 2 is off. Timer 2 on. So here you can see timer 2 on bit we used. Yeah, that is about the bits. So I want to get interrupt generated after 250 ticks. So I return here you can see this is the main.c and timers.s and isr.c. So now I want to get interrupt generated after 256. So in the previous code I written TMR equals to 6, but here no need to write TMR equals to 6. You need to write PR2. PR2 is there, right? It is a special register. Here we having, instead of writing TMR equals to 6 and all, here you can write PR2 equals to 250. Then what will happen? Timer starts ticking from 0 to 250. So this is the advantage in the timer 2 register. Then I can achieve 256 so what will happen here? Every timer starts from 0 to 250. So, and next is the TMR to IE equals to 1. The timer interrupt is enabled. In timer 0, ticking starts from 0, 1, 2. When it reaches 255, rollovers to 0. Definitely it have to reach 255, but here you could start from somewhere in between, and you could start from either 20 like that, either 6, but here we have one special register, that is period register, right? So the timer keep ticking until data which stored in period register. So if period register have value 250, then it ticking up to 250 like that. So this is one special advantage. So now click build. So here we having some warning, right? Init timer 0 is never called. Yeah, here. So go to the init timer 2. It is init timer 2. Sorry, it is not init timer 2. Init timer 2 is this one. Again click build. Okay, there is no warning now. Now go to the PICSimLab Simulator and here click file, load hexa file, and here 1 second timer, that is timer to distributive, default, production and hexa file. See, LED is toggling now. Let's configure timer 0 as counter. Okay, I'm going to open the code. So I'm going to close this one and going to open project timer as counter. Okay, let's configure timer as counter. So here timer 0 as timer. So ticking happens. It depends on instruction cycle. So what if timer 0 as counter? Then what will happen? If timer 0 as timer, then ticking happens, that is depends on instruction cycle. If ticking happens when event occur, then timer 0 is configured as counter. So in the example, event occur, in the given example, in this code, when event occur, okay, let's open the project. Here source file, just click on the main.c, and here we also having timers.c and isr.c, and we also having header files, that is main.h and timers.h. So in the example, event occur, assume when switch is pressed. Okay, now open the data sheet. So counter mode is selected by setting bit T0CS. In the counter mode, timer 0 will increment either on every rising or falling edge of pin RA4 or T0CK1. In counter, ticking happens only after event occur. So here T0CS equals to 1 when you select only when internal clock is selected, isn't it? And here you can see sorry, what I said, T0 CS equals to 1 when external clock is selected. T0 CS equals to 0 means internal clock is selected. Okay. So here they mentioned in the counter. In counter mode, timer 0 will increment either on every rising or falling edge of pin RA4. So pin RA4. Yeah. So this is what PICGenios board. So now in PICSimLab, in PIC microcontroller, none of the configuration done to RA4 pin. So what to do now? I want to configure RA4 pin. So how to configure? But here any peripheral is connected to RA4? No, right? So how to configure this? So I will make sure to use some spare parts here. So how to use? Go to the modules and here click spare parts. So here we having spare parts. So now here you need to add. So now here we need to add the RA4 pin peripheral. So here this is not required. I am going to delete this and here this one also. So here inputs I am going to select, I am going to add the push button. So here we got push button. So I want to make use of only one. So how to use? Here we having so many buttons are there. Right click, then here you need to click properties. So here I am going to choose this pin. So here I am going to choose RA4. So we need RA4 pin, isn't it? So I am going to choose RA4, then click OK. Yeah, now spare parts. Yeah, now we having RA4 pin, isn't it? So now here T0 CS equals to 1 and here T0 SC equals to 0. Why it is 0? Here you can see in counter mode, timer 0 will increment either on rising edge or falling edge of pin RA4. So we need to use either rising edge or falling edge. So here you can see T0 SE. So the incrementing edge is determined by the timer 0 source edge bit. Select bit. Edge select bit means T0 SE equals to 1. Means what? Incrementing edge. So T0 SE, yeah, clearing bit T0 SE means what? It's selecting the rising edge. What it's saying, if you want to select the falling edge, then what you need to write? You need to write T0 SE equals to 1. So if you want to select rising edge, then you need to write T0 SE equals to 0. Here in the code we are going to use T0 SE equals to 0. Means here we selecting the rising edge trigger. let's see how the configuration done in push button. So how to see? Here you need to select help, and here we having contents and about. Developed by this version. This is about, right? Contents. Click contents. Yeah, then you will get this page. So here we need push button, right? So here we having so many. Click to push button. So this part consists of 8 push buttons, but here I am going to use only one push button. So here you can see the diagram. So when switch is open, you are going to identify 0. When switch is closed, you are going to identify 1. So if switch is pressed, which is the edge you are going to identify? Rising edge or falling edge? Rising edge, isn't it? And here you can see this is pull down or pull up. This is pull up. So here, since it is rising edge, I am going to write T0SE equals to 0 here. So no scalar concept used. When you press, what will happen? So here you can see the what need to happen when you press this button. Let's see the output. So when you press the switch, the ticking happens from 0 to 1. So if you press again, it happens from 1 to 2. To get interrupt generated, how many times we need to press? Up to 256 times. So to press 256 times, it takes too much time, right? You need to press 256 times like this, 1, 2, 3, 4. It needs huge time. So in the code, so we need to generate interrupt, right? So what I am going to write is TMR 0 equals to 251. So now we need to press 5 times to reach 256, isn't it? 251, 252, 253, 254, 255, then 250, then it rollovers to 0. So okay, here you need to click build. After build successful, go to the PICSimLab, and here I am going to write, keep like this. So here click file, load hex, and here you need to choose timer as a counter, distributive, default, production, and hexa file. So where we having spare parts, so I am going to keep like this. So now you need to press 5 times. So 1, 2, why it's on? Okay, I pressed it long time ago. So let's reload last. So now okay, some issue is there. Okay, so here reset, then here load hexafile timer as a counter. So press 1, 2, 3, 4. You need to press 5. Still same issue, right? Why? Okay, let's go to the spare parts. Here click properties and here mode. Just change the mode normal to ideal, then click OK. Now let's check the output. So before that, yeah, okay, so now I need to press 5 times, right? 1, 2, 3, 4, 5. LED turns on. Again 1, 2, 3, 4, 5. LED turns off. Again check. On, off. Sorry, on, off. 3, 4, 5. On. 1, 2, 3, 4, 5. LED turns off. So that's all about the today's session. In the next session, let's discuss about, in the next session we are going to discuss about clock in out. So that's all about today's session. Thank you all.